Get me organized.
Everybody ready? You ready? All right. 1, 2, 3.
Hi, everybody. Welcome back to Make the Grade. I am Caroline Richardson, and I'm here today between 4 and 5 to answer your math questions. So what I need you to do is as you watch the screen, a phone number is going to come up across the screen or a website, and you can call me. And if you have a question on something that you're working on in math right now, I got some news from the Algebra 1 teachers that you guys are working really hard on factoring, and there's some geometric mean and trigonometry going on in geometry. And whatever it is you're working on, if you're stuck on something, give me a call, and I will help you through it. If you have a homework problem or an extra credit problem, or you just have a test coming up and you're not quite sure how to do something, okay? And if during the week you have some questions, here is the website. It's mathhelp@wcpss.net. And then real quick, here's the phone number, 217-2203. And now you don't even have to have the TV. All you have to have is the computer. If you go to http://ewtv.org.org, if you go to that and look for the live link, you can see us live via the computer, so you could be anywhere. If you have a math question, give us a call, okay? So anywhere in the world, if you have a math question, you can give me a call, okay? All right. So let's see. I told Algebra 1, I was told that there was some factoring, so if I have time, I'll just review some factoring problems. Otherwise, give me a call about it. Some geometric mean and trig problems, and we have EOGs coming up soon, middle schools. I know those are on the way. And guess what's this weekend? Yes, the SAT. So what I thought I'd do today is I'd start with a few SAT problems that I thought were really good. They're going to be also dealing with some of the other topics that the teachers were concerned about, but we'll put them in SAT sort of form today, okay? All right, so let's start with the first problem. This is what I'm going to call SAT1. And you know what I forgot to do is I forgot to write down the multiple choice answers, which is real important, because this being an algebra problem, this certainly wouldn't be a grid in, okay? Let me write these down so we have them. Sometimes it's good to look at your answers when you're doing an SAT problem. Other times it is not. Ever since you discovered answers in the back of your book, you can work towards any answer. In fact, look at me. Remember that day you found the answers in the back of your book and your teacher assigned 1 through, 19 odd, and they were in the back of the book, and you're like, oh, the answer's 10. And you started working on it until you got to 10. Very, very nice, wasn't it? Okay. Then all of a sudden the next teacher started giving you 2 through 20 even, and you're like, oh, I don't have the answers. Okay, the problem sometimes with the multiple choice test in math is that one of those answers is there. That's the good part, okay? But it's not like, say, English or history where you kind of have a feeling about it. You can't really say, it feels like 3. It doesn't really work that way. The other problem is going to happen is that all of a sudden you're going to see an answer on the screen and you're going to want to solve for that answer, okay? So I guarantee that the A through E that's on here, if I work hard enough, I can do some algebra and solve for any one of these answers that are on here, okay? So that's what you have to be careful. But you do want to look at the multiple choice answers to see what type of answers you're looking for, okay? So look at these real quick. On this problem, and let me zoom in just a little bit so you can see. There we go. On this problem, when you're first given the problem over here, 4x plus 4y over 2x squared minus 2y, you might start thinking, oh, I have to solve for x and y. No, if you look at your answers, none of these answers say x equals 10 or y equals 10, okay? So what you want to do is you're going to be simplifying this problem, not actually solving for anything, okay? All right, so let's look at this. It says we have 4x plus 4y. Let me see. Let me push this back up for you. There we go. 4x plus 4y over 2x squared minus 2y squared, okay? This is something that some people will do, okay? You're going to see the 2 with the 2 here and an x, so there's an x on the bottom, 2 with the 2, the y's cancel, you're left with a y, so that leaves you with 2 plus 2 over x minus y, so that's 4 over x minus y. No, 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 bad, bad. This is what I'm going to tell you. You see this 4x plus 4y and this 2x squared minus 2y? They're families. You got to always protect the family. You hear me? You don't ever try to cancel things out unless you cancel everything out with a family. You got these pluses and these minuses going on here. Always protect the family. All right? So we look at this problem again. 4x plus 4y over 2x squared minus 2y squared. We're going to protect the family.
Okay.
So what can we do to start simplifying that now? What I would start doing now is I would see if I could find a GCF, okay? See if you could factor something out, because we can't cancel anything going on here. On the top, we have a GCF of 4, so that leaves us with x plus y. On the bottom, we have 2x squared minus 2y squared, so we have a GCF of 2, which leaves us with x squared minus y squared, okay? Now, here we are again. Can you cancel the x squared, y squared, and x and y and be left? No, no, no. You've got a family, okay? Protect the family at all costs. You understand me? All right. Well, what we can do is we can reduce the 2 with the 4. 2 goes into 2 once. 2 goes into 4 2 times. And now, this answer isn't on our choices A through E, so that is telling you that you do have to go a little bit further. Where is that little bit further? Well, you have to remember this pattern right here. This is the difference of two perfect squares. The difference of two perfect squares always factors to be x minus y, x plus y. We call those conjugates. All over 2 times x plus y. Now, see here we have an x plus y family and an x plus y family on the numerator and denominator. Families can cross off families, okay? Now they're gone. Final answer, 2 over x minus y. 2 over x minus y. Always double check your x's, minuses, and pluses. The answer is E, okay? Be very, very careful that you always, 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 let me widen it out here a little bit, always, always, always protect the family, okay? All right, let's try another SAT problem. Was that a call or not really? Okay. All right, let's look at SAT problem number 2, okay? If h equals x squared minus 1 over x plus 1 plus x squared minus 1 over x minus 1, what is x in terms of h, okay? And then you see these answers. What does this mean? What is x in terms of h? That means that your final answer is going to be x equals something, and h will be in there. So some numbers with h somewhere in there, okay? So basically, we're solving for x. Now, when you look at this problem, the very first thing you see is the fractions, okay? So a lot of people are going to say, oh, I need to find common denominators and start dealing with that. Before you start going into the common denominator world, see, I thought I wrote these big enough, but I'm not sure if y'all can see them, so let me zoom in a little bit. Is that better? Okay. So before you start trying to find common denominators, what I'd like you to do is if anything can be factored or a GCF can be found, do that first, okay? So h equals, this top one is the difference of two perfect squares. So what does it factor into? The conjugates. X minus 1, x plus 1 over x plus 1 plus, this is the difference of two perfect squares. X minus 1, x plus 1 all over x minus 1, okay? Now what did I say you can do? A family can wipe out another family, right? So x plus 1 cancels with x plus 1, x minus 1 cancels with x minus 1. We now have h equals x minus 1 plus x plus 1. That is a lot prettier to look at. If you started going down the path of finding a common denominator, you would have found the correct answer, but it would have taken you a lot more effort and a lot more work, okay? Always try to factor, look at me, always try to factor and simplify a problem as much as you can before you start trying to do the arithmetic, okay? Let the algebra help you. The algebra is there to manipulate the problem so that it can become a little bit simpler, okay? All right, so if we go back and solve, we haven't finished the problem in that it asked us to solve for x in terms of h. So let's simplify this side. X equals x minus 1 plus x plus 1. The 1's cancel, so you're left with h equals 2x. Well, we have to solve for x, so divide both sides by 2. we're left with x equals h over 2. That is an answer of x in terms of h, where the other variable is h. Sometimes you see that a lot. Y in terms of x is normally the way you see it. All right, so if we come up here and look at our answers, h over 2 would be A. Okay, great problem. All right, SAT problem 3. Okay, don't forget to call. I'll remind you of the phone number. Call me. You must have some homework you're working on, okay? I know you're off on Friday, but that means there's probably tests coming up on tomorrow, maybe. It's questions, okay? So call me. Don't be afraid, just call. All right, stop. No singing. All right. SAT problem 3. By how much does the sum of the roots of the equation x plus 1 times x minus 3 equals 0 exceed the product of its roots? Okay, we need a little vocabulary going on here. Roots. What does roots mean? Roots means the answers, basically. Okay, it's another one of those words for the value of x where it hits the x-intercept, so it's the answer, okay, of the equation. So we don't have just an expression. We have an equation equal to 0. Exceed, and we also have to know sum. What is sum? Sum is addition. The product of its roots, product would be multiplication, okay? All right, so first thing we need to do is find the roots, I guess. So x plus 1 times x minus 3 equals 0. When you have factored and gotten to that level, then you need to set both of these equal to 0. X plus 1 equals 0. X minus 3 equals 0. Subtract 1 from both sides. You're left with x equals negative 1. Add 3 to both sides. You're left with x equals positive 3. Okay? So these are the two roots, x equals negative 1 and x equals 3. So the sum of those would be negative 1 plus 3, which is 2. The product of those would be negative 1 times 3, which is negative 3. And take notice that the number 2 is a choice up here. 3 is a choice. Even though it said negative 3, you might have thought you got the sign wrong. But that wasn't, negative 1 that popped up, 3 popped up, okay? Those are all answers that are trying to trick you, because the question was, how much does the sum exceed the product? So that means you basically have to find the difference between the sum and the product, okay? So what's 2 minus a negative 3? Well, 2 minus a negative 3 would be 5. The answer is E5, okay? You've got to get a handle on that vocabulary and be sure you're answering the question. Always go back and look. There's going to be questions on there that are trying to trick you, okay? And it's not a matter of, oh, they're trying to trick you. Sometimes the SAT and actually a lot of multiple choice tests that you're going to be taking, like the achievement tests and ACTs, it's not so much do you know the mathematics. We kind of know you know the mathematics, or we hope you do. Can you take the test? Can you think logically, and can you get some higher level thinking skills going on? And that's what they're really looking for, okay? All right, so let's do problem 4. Problem 4 is a grid-in, okay? Now, grid-ins. Come back. Grid-ins. I just have to say this because when you take the SAT, if you get you start working on your answers. I mentioned this last time, but you have been conditioned as a student when you're given a test, answer all the questions, okay? Even if you don't know how to do it, just guess, right? You're normally, if you get the question wrong, it's wrong. If you guess and get it wrong, it's wrong. If you guess and get it right, then yay, you got it right, okay? But you're going to get the same penalty that if you left it blank versus if you just guessed it and got it wrong. Okay, you have to change your thinking on the SAT. On the SAT, if you get it right, you get your point. You got it right. If you get it wrong, you lose 1/4 of a point. So for every 4 problems you get wrong, you lose a whole point, okay? So it's going to be better if you have no idea how to do the problem. It is safer and better for you to not answer the question at all, because you are not penalized for not answering the question. Okay, now there is a limit to that. You can't answer just one question and then not answer anything else and get 100 on it. It doesn't work that way. After a certain percentage of the test that you've answered, they're going to do some equation. I want to say it's about 3/4 of the test and then some of those questions. But we'll need to go online and double check that, and I'll try to do that for you, okay? You're not penalized for skipping. You could be penalized if you guess and get the wrong answer, okay? So unless you can get the answers down to just maybe say 2 choices, I wouldn't guess. It's not worth it. If you have a lot of time left over at the end, say you still have another 5 or 10 minutes left, then go back and take the time to work out those problems. Okay, now the grid-ins. The grid-ins no penalty. They're like freebies, okay? You do have to grid in your answer, which is that's not the problem. You do, and if you get it wrong, there's no penalty. If you get it right, you get that plus point, okay? So if you have extra time, I would focus my energy on the grid ins. Why? Because they're not going to penalize you, okay? The last thing is you really want to practice, 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 practice. Then when you have some more time, practice some more. Why? Because the math questions, you just have to learn the different types of questions that are out there. A lot of times, again, they're not solving the problem, but they're getting one part of the problem to look like another part of the problem, okay? It's not really about solving sometimes. Some of the questions are logic questions, okay? This grid-in is an example of that. It's going to sound like some question out of a comic book, but when you boil it down, it's just a very simple algebra problem, okay? All right, so let's look at this grid-in. If 5 sips plus 4 gulps equals 1 glass, and 13 sips plus 7 gulps equals 2 glasses, how many sips equal a gulp? Okay? How many sips equal a gulp? That's what we're looking for. Okay, now remember, this is a grid-in, so no choices. All right, so let's figure out what we know. We know that 5 sips plus 4 gulps equals 1 glass. And because I have a tendency to think more algebraically, I'm going to say 5s plus 4g equals 1, we'll have to call it GL. Okay, so I just make it look a little bit smaller. Then we also know that 13 sips plus 7 gulps equals 2 glasses. Okay, so 13s plus 7g equals 2 GLs, okay? Now, looking at this, you might be thinking, do systems of equations. It does kind of look like a system, and if you, well, it is, I guess, a system, because you have 2 variables, both equaling, in this case, 1 glass or 2 glasses, so this isn't really an unknown. This is the result. How are ways that you can solve systems of equations? You could graph them, you could do substitution, or you could do elimination, okay? This is more of a substitution type thing, and this is why. Is there any way that I can get these 2 equations to equal each other? Okay. Well, if 13s plus 7g equals 2 glasses, what if I took this top one and multiplied it by 2? Wouldn't that also equal 2 glasses? Sure would. So if 13s plus 7g, that's 2 glasses, equals 2 times the 5 sips plus 4 gulps, because that equaled 1 glass, right? So 2 times 1 would be 2. So here we've instantly done a quick substitution. It's not really about solving. Don't get your head all wrapped around going, oh my gosh, what's happened? All right, let's distribute. 13 sips plus 7 gulps equals, distribute the 2, 10 sips plus 8 gulps, okay? The question was how many sips equal a gulp, so we need to solve for gulps, right? Or solve for sips. So let's get S's on one side and G's on the other. So 13s minus 10s, let's subtract 10s from both sides, equals 8g minus 7g. We'll subtract 7g from both sides. We're left with 13 minus 10 is 3s, or 3 sips, equals 8g minus 7g is 1g, or 1 gulp. The question is, how many sips equal a gulp? The answer is 3. So you would grid in 3. It's a great problem. That is not a hard problem, but it is kind of a little bit of a logic problem. So break it down, get your information, look at me, get your information organized on the sheet, and then sometimes, like I did, convert it maybe over to algebra or abbreviate a little bit so it doesn't look so complicated, okay? All right, well, those are the 4 SAT problems I had picked out for you today. If we have time, we'll go over some more. Otherwise, I'm waiting for some calls. We got a call about some factoring. And this might be coming, is this coming from you, Eastwake? Because I know you guys are working on factoring. Oh, look, I'm taking a sip from my Applebee's cup. You know why? Because if you call in, Applebee's is going to give you a free dessert. So give me a call, okay? All right. Factoring. Things we need to remember. We need to remember some of our patterns, okay? And we need to remember grouping. And we need to remember, my pen. Okay, here we go. So when you factor, first thing, you always want to look for, let me zoom out just a little bit. First thing you always want to try is GCF. Is there a greatest common factor among them that you can reduce the problem just a little bit? Second thing, you want to look for some patterns. There's a lot of patterns out there, but the ones that are, I would say, that are the most important to remember are if you have something like x squared minus y squared, y, or why do we have to remember that one? That is the difference of two perfect squares. Difference of two perfect squares always factors to be the square root of the first one minus the square root of the second one, square root of the first one plus the square root of the second one, okay? What about x squared plus y squared? What does that factor to be? Think. Trick question. Right now you can't factor that. We call that one prime. That one does not factor, okay? X cubed minus y cubed and x cubed plus y cubed. I'm going to do these two together, so this is a good pattern. It's a binomial and a, I ran out of paper. Hold on. Don't want to write on my sheet. There we go. Ha. Am I still on the screen? There we go. So it's a binomial and a trinomial. Binomial and a trinomial, okay? First thing you need to do is take the cube root of both of these, okay? So basically you're taking the variable that's right there, that cube root. So it's x, keep the sign, y, x, keep the sign, y. Then the trinomial, think about if you were foiling this out. X times what gives you x cubed? X squared. X times what gives you x cubed? X squared, okay? Y times what gives you y cubed? Well, that would be y squared. Y times what gives you y cubed? That would be y squared, okay? The center term is the product of the two, x times y. X, y, x, y, okay? So now the problem is coming with signs. In terms of the signs, the y squared that's been squared is always positive, okay? So now we have to decide what we're going to do with this xy and this xy. Well, here's the catch. For the center term, which is what's happened here, that center term to be eliminated when you FOIL things out, you need one subtraction, okay? If you have more than one subtraction, then they won't cancel each other out, okay? Like just up here, see how there's one term that has a subtraction in it? It's the way I like to remember it. So this already has the subtraction, so this sign is going to be positive. And down here we have an addition, but we don't have any subtraction, so this one will be subtraction. So they're very similar to each other, you just have to be sure that you understand the signs. Okay? Those are the four patterns that I would strongly recommend you remember. The other one is a perfect square binomial. And for some of you, by the time you remember that this is a pattern, you probably have factored already, but it's square the first one, square the last one, and 2 times the product of the two. Okay? All right, so remember your patterns. Then, after patterns, let me go back out again. After patterns, you may have to try some sort of grouping to find the answer, okay? These 4 problems, I'm not quite sure what they're going to turn out to be, but I'm going to look for GCF first in all of them. Then I'm going to look for patterns, and then if I can't do anything, I'm going to look for some grouping, okay? Now, if these had been equal to something, say equal to 0 or equal to 1, then you would have to go on and solve the problem, in which case you might be able to use the complete the square or quadratic formula, okay? You cannot use complete the square quadratic formula unless, well, that's a little bit of a fib. Complete the square you might be able to use if it's not an equation. Those of you in Algebra 2 have been working with parabolas, right? You've done that with standard form. But quadratic formula definitely is equal to, okay? All right, so let's factor these. Yay, we love factoring. Can't lose that. I was trying to get my scrap paper and I found something on it. All right, so let's look at this first one. 3x squared minus 27, okay? All right, 3x squared minus 27. First thing, GCF. Do we see a GCF? Yes. This first term has a 3. They both can factor out a 3 into them, okay? So let's do that. So we'll factor out a 3. Now, the 3 doesn't disappear, okay? It just factors out. Or divides out is another way of looking at it. So 3 divided into 3x squared leaves us with just x squared. Minus 3 divided into 27 leaves us with 9, okay? X squared minus 9. Now, are we done? Well, we tried GCF. Now we have to look at this as a pattern. Yes, this is a pattern. This is the difference of 2 perfect squares. Difference of two perfect squares, what do we need to do? It factors into x minus, what's the square root of 9? 3. X plus 3. That's your final answer. Okay? Good job. All right, let's look at another one. Or the other one that was on that sheet. 6x squared plus 7x minus 5. Okay? Looking at this first one, do these have anything in common? GCF. Does 6x squared and 7x have anything in common? And 5? No, they don't. Okay? So is this a pattern? Is this the difference of two perfect squares? Difference of two perfect cubes? No. This is just, it's actually just a quadratic, right? So now what? So now the last thing was grouping. Okay? The better you can master grouping, the easier life is going to be in terms of factoring. And you guys, factoring is not going away. Those of you who are working on it in Algebra 1, you're going to have to use it in Geometry, in Algebra 2, in Algebra 3, in Calculus. It's not going away, okay? So you want to master it. So what I always call this, I call this the A times C, and I put plus B, okay? Because I want two numbers that are going to multiply to give me the value of A times C and plus B, and add up to give me B. What am I talking about A, B, and C? Well, if I were just to write this in the standard form of a quadratic, I would have ax squared plus bx plus c, okay? There's my standard form. Hopefully you can read that through the squiggle. Well, not really. Let me put it up here. Ax squared plus bx plus c. So the coefficient in front of the x squared term is the a, the coefficient in front of the x is the b, and then the constant is the c, okay? So I'm going to multiply the first and the last term together, just the constants. So 6 times negative 5 would be negative 30. And then I'm going to take the center coefficient, which is 7. So what do I want? I want two numbers that are going to multiply to give me negative 30. I feel like I'm not writing big enough for you all to see today. So call and tell me, write bigger, write smaller, zoom in. All right, so I need two numbers that are going to multiply to give me negative 30, but add up to give me 7. All right, numbers that multiply to give me negative 30. Negative 15 and 2. Do 15 and 2 in any way, shape, or form give us 7? No, they could give us 17, or they could give us 13, but not 7. How about 30 times 1? That could give us 31, or could give us 29. That's not helping. What about 10 and 3? That can give us 13, or 7. All right? But it has to multiply to give us negative 30. So how are we going to get positive 7? Well, you'd want positive 10 and negative 3. Okay? So there's our pair. Positive 10 times negative 3 is negative 30. Positive 10 plus negative 3 is 7. We found our pair. So what do you do with that pair? Well, you break up the center term. Okay? So we'd have 6x squared minus 3x plus 10x minus 5. Where all I did was say that 7x is the same as negative 3x plus 10x. Now, it doesn't matter what order you put those in. All we've done is rewritten the equation. We haven't changed anything. All right, next thing you do is you group the first two and the last two. So we're going to group 6x squared minus 3x and group the 10x minus 5. Then we're going to do a GCF of both of those. What do 6x squared and 3x have in common? Well, they have a 3x. So that leaves us with 2x minus 1 plus, what do 10x minus 5 have in common? They have a 5. So that leaves us with 2x minus 1 when we factor that out. So do you see how they both of these terms, here's the first term, here's the second term. Do you see how they both have a grouping in common? All right, well, they do. So they have that grouping, so you can factor out that grouping. So we're going to factor out the 2x minus 1. And then whatever's left, and sometimes what I do is I just put my fingers over it. Well, there we go. Get them in there on the screen so you can see. Put my fingers over whatever's left is the other factor. So in this case, the 3x and the plus 5. How can you check your work? You can go back and refoil that. Okay? So there's an example of grouping. All right, let's look at the next one. The next one says, oops, sorry, hi. The next one says 16y cubed plus 80y plus 100y. Oops, and I'm off the screen. There you are. Okay. All right. So what do we do with this one? Well, what did I say you do first? Always look for a GCF. Does this one have a GCF? It sure does. 16, 80, and 100. What do they all have in common? Well, you might say 2. Okay. You actually need to go bigger because actually 4 goes into it. But if you had put 2, let's just show you. We had put 2, we would have been left with 8 y cubed plus 40 y. Oops, I think that. Let me look at my original problem. I bet that was supposed to be y squared. Because then there's a single y, right? Y squared plus 100y. Okay? Notice that 8, 40, and 100 also have something in common. Okay? So we can factor out another 2. So if we factor out another 2, then we're left with 4. Where'd it go? 4y squared. There we go. Plus 20y. Plus, how many times does 2 come out of, oh, see, that should have been 50. That's what was messing me up. There we go. Equals 25. Okay. All right, so what do we do next? I don't know. Put these together. Now, look also, they have a y in common, right? There we go. I got to get myself straight. Okay. Got to stay focused. All right, so they have a y in common, so let's pull out a y. So now that leaves us with 4y squared plus 20y plus 25. Okay? There we go. All right, so moral to this story, if I had seen that they had a 4 in common earlier, then life would have been a little bit better. Okay? So they have a 4y in common, so that would have saved us a couple steps. And I kept getting myself mixed up because, you know, sometimes I was taking out a 2, sometimes I was taking out a 4. So even as long as I've been doing this, which I'm not going to tell you how long that is, you want to be sure that you factor everything out. All right, so we've taken out GCF. So now what's the next step? The next step is patterns. Do we have any patterns here? No, this is not a difference of 2 perfect squares or 2 perfect cubes or anything like that. So now we'll do a grouping. Okay, so what I don't want you to do is forget about this 4y. Okay, this 4y is going to be in the final answer. So put a little ring around it, bring it down all the way if you want to. But we're going to focus on this part of the problem right here. Okay, so we're going to do a grouping with this. Well, what did I say? You multiply the first term and the last term. So 4 times 25 would be 100. And then we're going to take the center term, which is 20. We need 2 numbers that are going to multiply to give us 100, but add up to give us 20. All right, so let's brainstorm. 25 times 4. Nope, that gives us 29 and 21. Close. 10 times 10. 10 times 10 gives us 100. 10 plus 10 gives us 20. We found it. Okay? So we're going to break up the center term to be 10y plus 10y. Okay, we haven't changed anything. We're just breaking it up. Plus 25. Okay? All right, so now what? Now I said you group the first 2 and the last 2. So 4y squared plus 10y plus 10y plus 25. Now what do? We do a GCF from both of those. What do 4y squared and 10y have in common? They have a 2y. That leaves us with 2y plus 5 when we factor that out. What do 10y and 25 have in common? They have a 5, which leaves us with 2y plus 5. They both have a grouping in common, so factor out the grouping. 2y plus 5. And then whatever's left, 2y plus 5 is your other term. Now, this is where I said, remember, if you could remember what a perfect square binomial, how that factors out. Square of the first one's a perfect square, the second one's a perfect square, and the center term is the product of those. So if you can remember it, you certainly would have gotten here faster. So we can say 2y plus 5 squared. Now, is that the answer? No. So remember this 4y? Got to bring that down. That's one of our factors. Okay? So there you go. So there's an example of GCF and grouping put together. Okay? Now, if it is a multiple choice, look at me. The EOG coming up and SAT or whatever it might be, if it's a multiple choice question and you can't remember how to factor, one of your answers is there. Okay? So if they give you 2 factors and you're really good at doing the FOIL method, you're really good at doing the box, however it is you FOIL or however it is you distribute those 2 together, those 2 binomials together, you can just take all 4 of your answers or 5, whatever it might be, and just go ahead and work backwards and see if you can get back to your original part of your question, okay? Remember, the answers are there. Sometimes, if it's a matter of speed, or if it's sometimes you're not quite sure how to do the problem, sometimes you can take the answer and substitute it back in, okay? Now, next week, I'm gonna meet on the 15th and the 17th to work on some of the EOG problems. I'm gonna do some EOG problems here today too. And then the end of the month, on the 29th, 30th, and 31st, I believe, I'm gonna focus solely on Algebra 1, Geometry, and Algebra 2 EOCs, okay? And I'm gonna be talking to you about some test strategies and things to look for. Sometimes you don't have to do the whole problem. Of course, I want you to know the math and be sure that you understand it, but I also want you to pass that test, right? So that's 25% of your grade. So sometimes you can just take the answer and, I hate to say it, plug it back in and get what you want, okay? And I'll show you some of those strategies later on. All right, so there was one more factoring problem, I believe, and then we have a call, which another call we'll take care of. And I'm reaching for my paper, okay? All right, here we go. Let's see, what was it? It was 8x cubed plus 125y to the 6th. All right? Now, is there a GCF? 8 and 25, no GCF on that one. What else can we look for? A pattern. 8x cubed plus 25y to the 6th. Well, it's not the difference of two perfect squares, but if you look hard, it is the difference of two perfect cubes. I strongly recommend you learn your perfect cubes up to at least 6 so that you recognize these numbers. Now, how do you know if a variable is a perfect cubed? Well, if a variable is a perfect cube, the exponent is going to have a power of 3, or not a power of 3, it's going to be a multiple of 3. So here 3 and 3 times 2 is 6, okay, so those are multiples. All right, so what did we have to do? Well, this is the sum of two perfect squares, so it's going to factor to be a plus b, a squared minus ab plus b squared. So the first thing we need to do is figure out what a and b are. A and b are the cube roots of these two terms, okay? So a, what is the cube root of 8? Cube root of 8 is 2. When I say cube root, I mean what number times itself 3 times will give you 8. And what's the cube root of x cubed? Well, x, right? Our b term, 125y to the 6th. What is the cube root of 125? That would be 5, because 5 times 5 is 25, times 5 is 125. Cube root of y to the 6th would be y squared. So we have our a and our b. Don't look at the original part anymore, because I think that's where some of the errors pop in. All right, so now we're going to complete this pattern. A plus b, so that's 2x plus 5y squared. And then a squared, so 2x squared would be 4x squared. And look, 2x times 4x squared is 8x cubed. That's what we wanted. Minus a times b, what's 2x times 5y squared? Well, that would be 10xy squared. Plus b squared, which would be 5y squared squared, would be 25y to the 4th. Does that work? Yes. 5y squared times 25y to the 4th. 5 times 25 is 125. Y squared times y to the 4th is not y to the 8th. You add y to the 6th. Okay? So there's that one's factored. And that's the best you can do right now. Okay? All right. Excellent. All right. Well, that was perfect timing. Let's look at this one. From Westlake Middle School, Miss Kelly's class. Factor completely. 81 x to the 4th minus 16y to the 4th. Everyone missed this problem. Uh-oh. So Miss Kelly gave you all a stumper. So let's look at this one. First thing, what did I say? I want you to look for GCF. Do 81 and 16y to the 4th have, or 81 and 16 have anything in common? No, they do not. Okay? All right, so the next thing we're going to do is we're going to look for patterns. Difference, it's a difference. So is it the difference of two perfect squares or two perfect cubes? Well, 81 is a perfect square. 9 times 9 is 81. X to the 4th is a perfect square. Why? Because it's an even exponent. 16 and y to the 4th, both of these are perfect squares. So this is the difference of two perfect squares. And we said that the difference of two perfect squares, if you had a squared minus b squared, will always factor to be a minus b, a plus b. All right, so let's go ahead and look at this one. 91x to the 4th. What is the square root of 81x to the 4th? Well, that would be 9x squared minus the square root of 16y squared would be, right? 4y squared, okay? So 9x squared plus 4y squared. They're conjugates. They go together. So we're all done, right? No. You always need to look. Sometimes these are trick questions, and I'm thinking Miss Kelly tricked you because she wants you to look at this just a little bit harder, and you have to check each one of your factors to see if they factor, okay? So we'll start with this one. Is there a GCF here? No. Is this a pattern? 9x squared, that's a perfect square. 4y squared, that's a perfect squared. This one can be factored. This is the difference of two perfect squares. What is the square root of 9x squared? Well, that would be 3x minus, what's the square root of 4y squared? That would be 2y. So it's 3x minus 2y and 3x plus 2y, okay? Now, what about this one? 9x squared plus 4y squared. That's the sum of two perfect squares. And what did I just tell you about the sum of two perfect squares? It's prime. It's not going to factor anymore. So you're left with 9x squared plus 4y squared. Now is the problem done? I don't know. Let's go back and check our factors. Can we do anything with 3x minus 2y? No. Anything with 3x plus 2y? No. And we know that we couldn't do anything with this last term, so guess what? Now this is factored, okay? Now I'll tell you another one that's very tricky is whenever one of these original factors is a 1, 1 is a perfect square. So always watch that you can take it down just a little further, little further, little further, okay? Great question. Okay. Thank you, whoever called for Miss Kelly's class. All right, from Knightdale High School, Carrie. Oh, you guys are working on, I heard about this from Miss Wilkes and a couple of the other teachers. Y'all are working on geometric mean and trigonometry. All right, first thing, let's get organized, geometric mean, okay? Geometric mean is when you have a pattern, a proportion, a very special proportion, and that proportion is when you have a numerator and a denominator of a proportion that match, okay? And then we'll say A times B. So if the numerator of one ratio is equal to the denominator of another ratio, this is known as a geometric mean, okay? So you would say the geometric mean between A and B is X, okay? Now what is the relationship, or what is geometric mean? The best thing I can do, and it comes from a famous problem, it's called the gear ratio. Think of, I don't know if you all have, look at me. I know any of you have a 10, like a 10-speed bike, a bike that has gears, or if you've ever seen inside a clock, okay, or inside a, well, you'd have to look at a little watch. I always remember the movie Mouse Detective. I don't know. Anyway, where they're up in the clock. When you have gears that work together, and some of you just might have a little brother or sister that has a toy that has gears. But with the gears, what happens is you have those the little spiky things in the gear. Cogs, thank you. I knew that was something. Okay, so the official name is cogs. And when they go together, one turns, pushes like this one. If this is pushing down, it's going to turn the other one, right? So one of the things you can do is you can have a very, very tiny gear fit into a little bit bigger gear, fit into a little bit bigger gear, and so on. So you could go and crank real tiny, and you could start turning this huge windmill, okay? And that sounds silly. So what I want you to picture is that you've got a little gear, a medium gear, and then a large gear, okay? And this is really a ratio, or doing a proportion of something small to something large, something small to something large, okay? So really it's a ratio of small to large, but it turns out that they have something in common. So what's going to happen here is that the geometric mean is basically the middleman that helps the small and the large communicate to each other. All right, so that's the moral and that's the history behind it, which I know you were very excited to hear about. So how does that factor into this problem? Well, there are two theorems that you need to know. Now, you actually don't have to know the theorems. If you want, you can remember a very simple fact, and that fact was that if you have a right triangle, which we do, and the altitude is dropped from the right angle to the hypotenuse, it creates three similar right triangles. It creates a small right triangle right here, a medium-sized right triangle right here, and a large right triangle right here, okay? Small, medium, and large. So what you could do is you could set up a proportion between the small, the medium, and the large. You could set up some proportions and you can solve for the missing parts, okay, Carrie? However, there are two theorems that will make your life a lot easier, okay? The first theorem says that an altitude, all right, first of all, if you have dropped the altitude from the right angle, that the altitude is the geometric mean between the two parts of the hypotenuse that were created. So I'll call that part 1 and part 2, okay? The second relationship says the leg of a right triangle is the geometric mean between its adjacent part and its whole hypotenuse. All right, there we go. These two right here is what's going to help us with this problem. All right, so what can we do? Well, what we can do is use these two theorems and set up as many equations as we can to try to solve for this, okay? Because we're trying to find W, X, Y, and Z. All right, so what do we see? The altitude is the geometric mean between the two parts of the hypotenuse. So 8 is the geometric mean, and whenever I do that, I draw the ratio and put my two parts in between the two parts of the hypotenuse. Okay, that one is a very workable equation because I only have one unknown, right, W? All right, another one is the leg, so Y, is the geometric mean between its part, 6, and the whole hypotenuse, X. That's not a very good one to work with because I have two unknowns in that one, okay? Let me kind of go off to the side so everything fits. The other one, we have another leg over here of the big. Now, I'm always looking at the big right triangle when I do these theorems. And that is Z is the geometric mean, because it's the leg, between its adjacent part, W, and the whole hypotenuse, X. That's definitely not one we want to deal with because we have three unknowns in that one, okay? All right, so let's deal with what we have and what we can solve with. So we can find W very quickly in this case. Hold on a second. Make my paper a little smaller so we get everything up in there. There we go. All right, so I'm going to cross multiply to solve. Get your picture down in the screen. Okay, check. Cross multiply to solve. So that leaves me with 64 equals 6W. Divide both sides by 6. I'm left with W equals 32 thirds, which is 10 and 2 thirds. Okay? So 10 and 2 thirds. Find out what format your teacher wants the answer in, Carrie, so that you know you're getting the right thing, or you're putting down the right answer. All right, so now that we know what W is, here's W, 10 and 2 thirds. We can find X very quickly, right? Because X is equal to 6 plus W. Now we know what W is. So X equals 6 plus 10 and 2 thirds, which is 16 and 2 thirds. So that was a nice one, 16 and 2 thirds. Of course, what's scaring me now is that we've done these we've done the easy ones and we've come up with some, not too ugly, but a little bit ugly fractions. So I'm guessing that our next pattern is going to be not so nice. But you know what? Fractions are people too, so we can deal with them as well. All right, so in this proportion, we have Y and we have an X, two unknowns, but you know what? We just solved for X. We know what X is now. So we can say Y, which is the leg, is the geometric mean between X, which we just found to be 16 and 2 thirds, times 6. Cross multiply, we're left with Y squared equals 100, if you multiply that in your calculator. Take the square root of both sides, we're left with Y equals 10. Y equals 10. Now, at this point right here, I could have, noticed that I have the 6 and the 8. I could have just done Pythagorean theorem. This is actually a 3, 4, 5 triangle. Okay, so you could have found Y using Pythagorean theorem as well. And the last proportion, I'm going to go ahead and stick with this proportion so you know it, is the leg, Z, is the geometric mean between W, well, we just found W to be 10 and 2 thirds, times X, which is what? 16 and 2 thirds. Whew, that's pretty. So Z times Z, make sure you can see everything. Z times Z is Z squared equals, and 10 times 10 and 2 thirds times 16 and 2 thirds. Type that into your calculator, left with Z squared equals 1600 ninths. And actually, you guys, that actually is very pretty because, and let's go ahead and review a radical rule right here. I really don't feel like y'all can see this today. There we go. We take the square root of both sides. The square root, here's a basic rule. The square root of a over b is equal to the square root of a over the square root of b. Okay? Remember that rule? Okay, well, if you don't, I just reminded you. So z equals the square root of 1600 over the square root of 9. Both of those are perfect squares. The square root of 1600 is 40. The square root of 9 is 3. So z equals 40 thirds. 40 thirds, okay? So that was not too bad. Let the calculator help you with the arithmetic, Carrie, but you do have to remember some basic principles. One, in a right triangle, if an altitude is dropped from the right angle to the hypotenuse, it creates 3 similar right triangles. Those 3 similar right triangles, you can set up proportions, or you can learn 2 theorems where the altitude is the geometric mean between the parts, or the leg of the big right triangle is the geometric mean between its adjacent part, and the whole hypotenuse. The key is the first part of it, okay? All right, I hope that helped out, Carrie. All right, we got another call from Nightdale High School, Jason. All right, so this looks like a very similar problem, Jason. We have a triangle. Whoops, come back down. We have a triangle with sides 13, 20, and we've dropped from the vertex down to the opposite side. We made a right angle, so that's an altitude, and we have another side that's 21. So the very first thing that should go through your head is, oh, I'm trying to find an altitude. So you know when triangles look like this, that the altitude is the geometric mean between the 2 parts of the hypotenuse, right? But you know what? There was an if part before that, and it said, in a right triangle, so in a right triangle, the altitude is the geometric mean between the 2 parts of the hypotenuse. Is this big black triangle here that I'm pointing to a right triangle? Well, it looks just like, hold on, let me grab the problem I had before. It kind of looks just like this problem, doesn't it? Okay, in fact, have you ever done those hocus pocus things, Jason, where you try to figure out what's different? If we forget the numbers, there's one key element in this problem that's different. And that is, do you see how this top angle right here was marked? That those lines were perpendicular? So that implies that those 2 triangles, or that triangle is a right triangle. Do you see that marking in this one? No. Okay? So unless it's a typo, which I'm guessing it's not, if it's a typo, then you might want to talk to your teacher, but you might want to ask, but you can still solve this problem, okay? You're just going to have to rethink it. This is definitely a lollipop problem or a sucker problem. Lollipop, lollipop, oh, lollipop, lollipop. Okay? Because your teacher really wants to make sure that you understand the conditions that were set up, okay? Conditions. That's all geometry's been all about, setting up the conditions, right? All right, so how would we solve this now, since it's not a right triangle to solve? Well, we do have at least 2 right triangles right here, and whenever you see right triangles, one of the things that should fly through your mind very quickly is Pythagorean theorem, okay? So what if we did Pythagorean theorem on this first triangle? I'm going to call this the small triangle right here. All right, well, oh, darn it, I don't have this leg. Well, sure you do. This whole length is 21. Let's just call the length of this leg x. So if this piece is x, then this other little piece over here is 21 minus x, okay? That works. All right, so let's do Pythagorean theorem with this first triangle. Leg squared plus leg squared equals hypotenuse squared. So x squared plus h squared equals 13 squared, okay? All right, then let's do this one. This one we can say that h squared plus 21 minus x squared equals 20 squared. Uh-oh. We have 2 equations with 2 variables. Now, you could do systems of equations, but you know what? One of the things you could do is we could solve both equations for h squared. Let's do that. So h squared equals 13 squared minus x squared. I'll subtract this parenthesis, and I'll have h squared equals 20 squared minus 21 minus x squared. Okay? All right, so how does that help us? Well, two things equal to the same thing are equal to each other. Transitive property, if A is equal to B, if A is equal to B and B is equal to C, then A is equal to C. So now I could say 13 squared minus x squared equals 20 squared minus 21 minus x squared. All right, Jason, don't be scared about this. This is not scary, okay? Now we just have to simplify the problem a little bit. And notice we've just got x's in there. All right, so 13 squared is 169 minus x squared equals 20 squared is 400. And then, Jason, what are you going to do with this? Okay, it's minus, what are you going to do with this? Okay? What I hope you're not going to do, Jason, is you are not going to say 21 squared is 441 minus x squared. No, 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 bad, bad, bad. Okay, don't do that. What does 21 minus x mean? 21 minus x squared means 21 minus x times 21 minus x. Okay? You need to factor that. Not factor that, you need to FOIL that. 21 times 21 is 441. 21 times negative x is negative 21x. Negative x times 21 is negative 21x. Negative x times negative x is x squared. 441 minus 42x plus x squared. Whew, that was close on my screen. Okay? That is what that equals to. Please be very careful that everybody that goes for Algebra 1 up through Calculus, be careful, be careful, be careful. All right, so let's put that over there. So it's minus 441 minus 42x plus x squared. All right? So let's go ahead and distribute that negative sign. We have 169 minus x squared equals 400 minus 441 plus 42x. Distribute that negative minus x squared. All right. Looks scary. Looks like we have a quadratic, but we don't. Look, you have a negative x squared and a negative x squared on both sides, so they're going to cancel each other out. So now let's simplify. We have 169 equals 400, or 400 minus 41, here, wait a minute. 400 minus 441 would be negative 41 plus 42x. Look at that. That is a nice, pretty little problem to solve. We have one single x. Add 41 to both sides. We're left with 210 equals 42x. Divide both sides by 42. We're left with x equals 5. Okay? All right, so all that work to get us to the point that x equals 5, that was up here. So this piece is 5. So now can we find the height? Well, we sure can. You guys, we knew what x was. Look, in fact, you have right here. H squared equals 13 squared minus x squared. Where's that coming from? Pythagorean theorem. All right? So if h squared equals 13 squared minus x squared, let's substitute in our x. H squared equals 169 minus 5 squared, which is 25. So h squared equals 169 minus 25. H squared equals 144. Square root of both sides. H equals 12. And that, Jason, is what you were looking for. Okay? And if you wanted to go ahead and finish this off, you could say 21 minus x is 16. There's all your missing parts. What I need to caution you on this one is be careful that this was not marked a right angle. Okay? So remember, look at me. So always look for those markings, and sometimes they can mix those problems up around other problems that have the marking with the right angle. Okay? All right. How much time have I got? I have no time. They're giving me the big 0. We're out of time. All right, so what I didn't get to today was going over some EOG problems, but I thank you for your calls. What we're going to do is next week I'm going to entirely focus on the EOGs for the middle school, okay, 6th, 7th, and 8th. So I'm going to be going over some practice EOG problems. I'm not saying the rest of you can't call in, but in terms of the review problems I'll be going over, that's what I'll be going over, okay? So I will see you next week, and I'm going to see you not on Wednesday next time, on the 15th and 17th, okay? Is that next week? No, that's 2 weeks from now. So starting next week, next Wednesday I'll be here. Oh my goodness, I've lost track. So next Wednesday and then the following Tuesday and Thursday, okay? And we're going to focus on EOGs for middle school. All right? It was nice to see you. See you next time on Make the Grade. Bye.